Hello students, in our previous module we discussed about potential energy and gravitational potential energy, and so far in this chapter we have discussed about work and different form of energy and how work done gets converted into energy inside an object. We have also discussed about the mechanical form of energy, that is your kinetic energy and potential energy. So here at this point, a simple question to all of you. In our everyday life, we come across various form of energy. So think of a situation where you are using electrical energy. So we know electrical energy we are using for lighting of our bulb, for running of your fan, TV or any other electronic gadgets. So in that case we see that electrical energy is getting converted into either your light energy or it is converted into heat energy. Now when this process is occurring, can we say that at the beginning of the process and at the end of the process, if you talk about the total energy of the entire system and the entire process, is there any change? Although the form of the energy has changed, can we say there is a change in the amount of energy? The answer is no. The amount of energy cannot be changed. That's what we know it as conservation of energy. And that states that energy can only be converted from one form to another. It can neither be created or destroyed. The total energy before and after the transformation remains the same. So to prove this, that energy remains constant, we will look at a situation and example. So if you look at the picture, we have a building. Let's the height of the building be h, and we have lifted that ball to the top of that height of the building, and from there we'll release that ball. Now dear students, think, the height of the building is h, that means the ball has been raised to a height of h. That means there has been an increase in the potential energy. So when the ball is at the height, at the topmost height, we can give the potential energy of that object to be your mgh. Let's denote it, that position, as your position A. Suppose we denote it by position A. At this position, the potential energy will be highest, the kinetic energy will be 0. You must be thinking, why the kinetic energy is 0? Because at this point the velocity of the ball is 0. We have not allowed the ball to fall. We have only raised the ball to a height of h. Hence, the potential energy will be is equal to mgh. M is the mass of the object, g will be the acceleration due to gravity, and h will be the height of the object. Now, if you allow the ball to fall, suppose it comes to a position of B, the height of that ball right now from the ground, if you take, it is less than h. That means if the height has decreased, the potential energy has also decreased. So reaching the height B, the object has reduced its potential energy. But from coming point A to B, it has acquired a velocity for which there is a increase in its kinetic energy. So the decrease in potential energy and the increase in the kinetic energy becomes equal. So we can say at point B, if you take the potential energy and the kinetic energy, the total will give us the initial energy. That means we can say here the energy is also constant. Because when you allow the ball to fall under gravity, under the force of gravity, at that time it will achieve certain amount of velocity. So as it achieves certain amount of velocity, we can say that there will be some amount of kinetic energy in that ball, and we will represent it. Suppose the velocity is v, then we will represent the kinetic energy as half into mass into the square of the velocity, half mv square. Now there is a decrease in the potential energy but increase in the kinetic energy. Let's allow that ball to fall again from the point B to a point C on the ground. Let the ball comes back to the ground and let's indicate it with the position C. Now at the position C on the ground, the height of the ball from the ground is 0, and we take the potential of an object on the surface or on the ground as 0. So here at this point the potential energy becomes 0, but the kinetic energy becomes the maximum or the highest. Before coming, just hitting the ground, when the velocity, the ball has not come to rest, just touches the ground, the velocity will be maximum, and that we know from laws of motion. Velocity will be maximum. So we can say the energy which is there in the ball is nothing but the kinetic energy, and we can say it is half mv square. So now if you see, the entire potential energy has converted into the kinetic energy. So here at this point, if you see, at the topmost height h, the potential energy is maximum and the kinetic energy is minimum, that is 0. And at the ground level, the potential energy becomes 0, but the kinetic energy becomes maximum. So if you take the sum of this potential energy and the kinetic energy, that will be remain always constant. That means at the beginning of the process and at the end of the process, the total energy remains conserved or constant. There is no change. That means energy cannot be created nor be destroyed. It cannot increase, it cannot also decrease. It can only be transferred from one form to the another form. Here in this case, the energy has transferred from potential energy to the kinetic energy. I hope all of you understood what is law of conservation of energy and how the sum of the potential energy and the kinetic energy of an object remains constant during a process. So if you want to express it in terms of an equation, we can say that potential energy plus kinetic energy is equal to constant, that is mgh plus half mv square will be is equal to constant. Now dear students, it's time to solve a numerical related to your conservation of energy or related to this particular equation. So here is the question in front of your screen. The question is, an object of mass 40 kg is raised to a height of 5 meter above the ground. What is its potential energy? That means at that height of 5 meter, what will be its potential energy? Next part of the question says, if the object is allowed to fall, find its kinetic energy when it is halfway down. So here, when the ball is allowed to fall, it will fall. That fall can be called as free fall. That means under the action of the gravity. So the acceleration that we will take here is g, that is acceleration due to gravity, that is 10 meter per second square. For the calculation, we will assume that. So all of you can give a try to solve. Here I am coming up with the solution to this numerical. So how can we solve it? Let's first summarize all the data. So the mass given, let's m is equal to 40 kg. The height to which it has been raised, h is equal to your 5 meter. So the potential energy P is, suppose we denote it, then it will be mgh, which is nothing but equal to 40 kg multiplied by 10 meter per second square, that is the acceleration due to gravity, and the height 5 meter. So that will give us the value as 2000 joule. So the potential energy at this height of 5 meter is 2000 joule. Now coming to the second part of the question. So coming to the second part of the question is that to find out the kinetic energy of the object when it is halfway way down. Half the way means here the height is given 5 meter. So half the way we can denote, let us assume at h dash. So we can write h dash is equal to h by 2, that is nothing but here 5 meter divided by 2, which is equal to 2.5 meter. So in order to find out the kinetic energy, if we can find out the decrease in the potential energy of the object from the height 5 meter to a height of 2.5 meter, if you calculate the difference in their potential energy, the decrease in the potential energy will get reflected in form of the kinetic energy. So here let us calculate the potential energy at this height. So the potential energy here, it will be again mgh, which is nothing but again mass 40 kg, acceleration due to gravity 10 meter per second square, and the height will be a 2.5 meter. And if you solve it, we get the value as 1000 joule. Now in order to find out the kinetic energy, we will take the difference of the potential energy. The decrease in the potential energy will get reflected in terms of the kinetic energy. So here if you look at the difference will give us the kinetic energy. So we will write Ke is equal to 2000 joule minus 1000 joule, which is nothing but 1000 joule. So here we get the answer as the halfway down the kinetic energy will be 1000 joule. So this is how we see the potential energy getting converted into the kinetic energy. Now dear students, if you try to correlate to the law of conservation of energy, at the mid height the potential energy is 1000 joule and the kinetic energy is also 1000 joule. So together it is 2000 joule, and the beginning at height 5 meter the energy was also 2000 joule. That means there is no change in the energy. So energy remains constant. I hope all of you understood this part. So as we have already discussed about work and energy, now the question is, do all of us work at the same rate? Do all machines consume energy at the same rate? The answer is no. A powerful person can do certain work quickly than a weaker person. A powerful vehicle can cover a particular distance in a less time as compared to a less powerful vehicle. So here we define the rate of work is nothing but how fast that work has been done or how slow that work has been done. So the rate of doing work is defined as power. That means a powerful machine can do or perform certain work very quickly, whereas a less powerful machine can do a certain work very slowly or will take much more time. So in order to understand the concept of power, let's take an example. So here let's take an example. Here a crane is lifting an object of 200 kg to a height of 10 meter. That means the crane is doing certain amount of work to lift that object to the height of 10 meter. So what is that amount of work done? So the amount of work done will be is nothing but force into displacement. Here the force will be nothing but the weight of that object, that is mass into the acceleration due to gravity, and as you can see the weight is nothing but 1960 Newton. So if you substitute that in the formula W is equal to Fs, then it gives us a work of 19600 joule. Now let's take another example. Suppose another crane will take, both the crane will lift that same 200 kg of object to a height of 10 meter. But the difference is that the first crane, which you can see as painted as yellow, takes 10 seconds, and the second crane B, painted as red, we can say takes 20 seconds. Now can we say that both of the crane are doing the same work? The answer is yes. The object they are lifting up is 200 kg. The height up to which they are lifting it up is 10 meter. So the amount of work done by both the crane will be equal. So if you put these values, substitute these values in the formula, you can see both the crane are doing same amount of work, that is 19600 joule. Now the question is, to perform the same work, one takes 10 seconds and another takes 20 seconds. So are they performing at the same rate? The answer is no. The crane A does the same work at a faster rate, which takes less time, whereas the crane B completes that work in 20 seconds, that means much slow than the first. So this expressing how fast the work has been done, we introduce the term power. And what will be the power here in this case? If you substitute that value, that will be work done divided by the time taken. And in the first case, you will find the work done will be 19600 divided by the time taken 10 seconds. So the power will be 1960 joule per second, and in the second case it will be 980 joule per second. So the power for both the crane will be different as they are consuming different time. So here we can summarize this all, that power is defined as the rate of doing work or the rate of transfer of energy. If an agent does a work of W in time T, then the power is given by work by time. Work, the SI unit is joule, time SI unit is second. So the unit for your power will be joule per second, which is nothing but expressed as watt. The unit of power is watt. So dear students, I hope you have understood how to define rate of work or how to express the power. So in order to understand it with more clarity, let's take up some numericals related to it. So here is one question. Two girls, each of weight 400 Newton, climb up a rope through a height of 8 meter. We name one of the girl as A and the other girl as B. The girl A takes 20 seconds while B takes 50 seconds to accomplish this task. What is the power expended by each girl? So we will use that same formula. power is equal to work by time. First we will calculate the amount of work done by both the girl A and girl B. Then we will find out the power of them as the time has been mentioned. You can also give a try and let's look at the solution to it. So here for the first girl or girl A, suppose we write it as the first one is girl A. The force applied is nothing but 400 Newton. The displacement of is nothing but your 8 meter. That means the work done will be is equal to F into S. That means 400 Newton multiplied by 8 meter. That will give us a value of 3200 Newton meter or 3200 joule. This is for girl A. The same way we can calculate it for girl B, as the force applied is same, displacement is also same. So for the girl B also will have the same amount of work, which is nothing but 3200 joule. But the power will be different because the time taken by girl A is different and girl B is different. So let's look what will be the power. So for the first girl, if you see for girl A, the power we can calculate as P is equal to W by T. The W here we had calculated as 3200 joule divided by the time is your 20 second, and that gives us 160 watt. And for girl B, if you want to calculate the power, so let's denote the power of the girl B as PB, that is nothing but work by time. The work done was 3200 joule divided by the time taken by girl B is 50 second. So the power will come it as 64 watt. That means if you compare the power of girl A with power of girl B, both of them are doing same work, the power is different. Power of girl A is more as compared to power of the girl B, because girl A completes the work in a less duration of time, hence power will be more. So I hope you understood and you are able to solve this numerical also. Next, let us take another numerical. Suppose a boy of mass 50 kg runs up a staircase of 45 steps in 9 seconds. If the height of each step is 15 centimeter, find his power. So, how to solve it? Mass is given. We can find out the force, that is nothing but mass into acceleration due to gravity. Number of steps is given, time duration is given, and height of each step is given. So let's solve this. Look at the solution. So here the force is nothing but mass into acceleration due to gravity. Mass was given as 50 kg. Acceleration due to gravity, let's assume as 10 meter per second square. That will give us a value of 500 Newton. Now the height of the staircase, let be h. The total height be denoted by h. Each step is nothing but your 15 centimeter. So we'll express it as in terms of meter. So that will be 15 by 100 meter multiplied by the total step was 45. Hence the height, if you solve, it comes as 6.75 meter. The time taken to climb this particular height is nothing but your 9 second. So let's t is equal to 9 second. Now as you know, power will be is equal to work done divided by the time. So work done will be is equal to mgh, time is t. So work done will be is equal to mg, we have already calculated, it's 500 Newton, multiplied by the height is 6.75 meter, divided by the time is 9 second, and if you solve it, the answer that you will get is nothing but 375 watt. So the power of that boy to climb a steps of 6.75 meter height will be 375 watt. There are plenty of numericals given in your NCERT textbook, NCERT exemplar. You can solve them. That will help to understand the concept in a better way. Now, in our everyday life also, we are using energy in our household, specifically if you talk about electrical energy. So the electrical energy that is consumed in our household by the use of different electrical appliances is a very large quantity. So in order to express this quantity, we cannot use joule. The unit joule is too small and hence is inconvenient to express a large quantity. So that's why we need a bigger unit so that we can express this large quantity of energy. And here we use that bigger unit, which is nothing but kilowatt hour. So how do we define it? How do we calculate that? So 1 kilowatt hour energy is used in 1 hour at the rate of 1000 joule per second. Suppose you have a device which consumes 1000 joule of energy per 1 second, and if you run that device or machine for 1 hour, the energy that will be consumed by that device will be expressed as 1 kilowatt hour. That means when a machine consumes 1000 joule of energy per 1 second, then the power will be 1 kilowatt. So the total energy that it will consume in 1 hour, that means 1 hour means 3600 second. So if you multiply that, 1 kilowatt is nothing but your 1000 watt multiplied by 3600 second, that gives you 360,000 joule, or we can express it as 3.6 into 10 to the power 6 joule. So that is the commercial unit that we use. And in commercial, we say 1 kilowatt hour is nothing but 1 unit. So dear students, this is how work, energy and power is related to each other, and this is how we find the uses in our day-to-day life. So we will conclude our lesson here. Let's recall what we discussed so far. We discussed how work gets converted into energy and stored in an object, how potential energy gets converted into kinetic energy, and how your potential energy and kinetic energy for a process which involves an object remains constant at the beginning of the process and at the end of the process. And we discussed about the rate at which work can be done. So before we conclude, let's take up the last final question for the module. So here is the question for you. An electric bulb of 60 watt is used for 6 hours per day. Calculate the energy consumed by the bulb. So it's very easy. The power is given 60 watt, time is given to you. So power into time is nothing but energy, because power is work by time, work is nothing but your energy. That means power is ultimately energy consumed in a given duration of time. So here we need to calculate the energy consumed by the bulb in 6 hours if the power is given to us 60 watt. So how will you calculate that? Let's look. So the energy will be is equal to power into time. Power is given as 60 watt multiplied by 6 hour. So if you want to express in terms of kilowatt hour, let's convert it into in terms of your kilowatt. So in terms of kilowatt, it will be 0.06 kilowatt multiplied by 6 hour, which is nothing but your 0.36 kilowatt hour. So the energy that will be consumed by the bulb in 6 hours will be 0.36 kilowatt hour. So dear students, read the chapter thoroughly, revise the concept, solve the numericals related to all this concept, and that will help you to understand this chapter in a better way. Take care. Thank you.